So looking at variadic parameters and arguments we could pass into them. Here we have a function greeting, and the parameters are, the first one is a variable prefix, and it's of type string. The second one is a variable who, and it's a type of variable number of arguments. And so when we call greeting, this first one here, hello, gets passed to string, and these two, James and Jasmine, get passed there. So any of the trailing strings get passed in. And then this code just prints the prefix, right, that one, and then for key value, and we're throwing away the key. We're going to range over who, that variable who, and print line the value. So we're printing out this value right there. And then here, instead of just, the first time was just greeting right up here. What changed is, okay, we had greeting, but now we're going to do a slice of strings and set that equal to s, and we're going to pass that in, and this is multiple things in this argument, s dot 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 dot, and and so that one here can pass over to that, and the same thing happens. And so we could have also done this, right? So instead of doing this line was the same, but then here we done s dot dot dot, but now I've changed this. Instead of taking dot 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 parameter, right, it's taking a slice of strings. So since I have a slice of strings, I can pass in a slice of strings. So that's just kind of cool to recognize how that works. If you got something, right, because this is sort of accessing the s dot 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 is accessing all the individual strings in here, passing them in. And that's what this wants, is just a bunch of individual strings. Just like right here, I gave it 2 individual strings, James and Jasmine. Right? Or if this is wanting a slice of strings, then I give it a slice of strings. So you just have to be really specific. It's strongly typed, right? And strict typing. What do they call that? It's not dynamic typing. I think that's what they call it, strict typing. So let me see if that's...
Strongly typed. That's what I heard, but that's the same thing.
I think so. Dynamic, static, that's what I'm looking for, static type. Not strict, not strong, static. I knew it was a ST, strict, strong, static, strict, strong, static. Static type, not dynamic type. But there are ways you can do dynamic stuff. So here we have a function taking in a variadic number of arguments of int. And so these are the different ways I could call it. I could pass in 2 ints, I could pass in 3 ints. I could have a slice of ints and pass in a slice dot dot dot. I could pass in nothing. And that's what it prints out. So heading back to the format package, anybody have questions?
Once you understand how this works, you understand how because it's the same thing. It's the same thing where it can take a varying amount of parameters in.
Yeah.
It's the same concept. So if you understand how that works, you understand how print.
Yeah. So here we're taking in a blank number of arguments of any type. That's what empty interface means, any type. And so here's sprint, which is string print. Sprint formats using the default formats for its operands and returns the resulting string. So printing to a string, basically. Spaces are added between operands when neither is a string. And we could do that with formatting verbs, and we could also do it with new lines. And we have scan, which is accept user input. Scan scans text read from standard input, storing successive space-separated values into successive arguments. New lines count as space. It returns the number of items successively scanned. And we saw that with, we saw that somewhat over here. Let me find it.
Are you doing a find? I'm sorry, I didn't do that.
Yeah, so I was looking for that code. The way I did that was I went to edit, find in path. And I said, look into this whole project, and I want to find scan. When I did that, it gave me all these results wherever I'd use scan and all this code. And I saw, oh yeah, that's the file I'm looking for. And I opened it up. And so here it found scan. And so here we say print intermeter swam. and I scan that, and I put it into the memory location right there, meters. Put it into that memory location. Which is kind of interesting, right? Like, okay, well, that's how that works. Let's look at the documentation. I mean, this is kind of the way I think about things when I'm at home. And that went in here, right? The memory address went right there. So scan scans text. Read from standard in, storing successive space-separated values into successive arguments. Okay, so storing successive space-separated values into successive arguments. So the arguments is into successive arguments. The arguments is where it gets stored into. And that needed here an ampersand, right? I'm not sure what would happen if I just said the variable name, not the memory address. We could try that. And but you know, that's learning the code and how it all works, just to play with it. Let's try it. Whoops, I didn't want to go that far. And I want to be in, put it here is technology. Where did that go? That was in find. And it's in 07 memory address is 02. 07 memory address is 02. 07, 02. And it's a go run, put it here. And so 100. And it converted it. Now what would have happened if this had just put it in the variable meters and not the address? Enter meter swam, 0 meters is 0 yards. That's weird, right? So it tries to put something there, it doesn't stop there. So it doesn't stop and wait for input, but when it's like this, it did.
So now you're trying to store that in there with the scan. Because
Yeah.
the scan's going to look for standard input.
And so, yeah, so if you wanted to investigate that further, exactly, that's what it does. I could click on that and I could look here and I can see, okay, scan A interface, and then, okay, OS standard in, it returns fscan, which takes OS standard in, and or calls fscan, which as arguments receives OS standard in, and then all of these A's, right? And that's, so it took this A here, scan, this function just calls and returns another function fscan, which has OS standard in. And standard in is a writer or a reader. I think it implements both. And so here is the argument. So we can look at fscan, see what fscan does. And here is that coming in. So it's a reader. And yeah, standard in is a reader. That makes sense. It's reading. And so here passes in A. And then A, do scan, S, do scan, so we could see what do scan is. And do, you know, it just keeps like going down this rabbit hole of looking at all the source code of Go, how Go works. But it's also a good place to sort of like see how Go code's written. And a lot of the stuff, hey, we know the 4 key value range. Even if you change, you know, this stuff right here from key value and call it whatever arg or throw away the first one, we know that. You know, we've got that figured out. And it's ranging over all those things that came in and then scanning one of them, you know, and V, maybe, I don't know what that stands for in the arg, right, is the what came in. Maybe that's value, key value, and scan 1. And then we can see scan 1, what scan 1 does. It just keeps going. It's like, wow, man, who thought of all this stuff and chained it all together? It's truly amazing. But, you know, ultimately what we're learning is like, okay, we learn the syntax and then we learn the packages and how do we use the packages. And then we learn design patterns. So that was just looking at scan. But that's how you own it, is to play with it. And so here's a format verb. I'm doing sprint here, not scan. But sprint string prints. And S, we never finished talking about verbs. So you could come here and you could look at all of the formatting verbs and let's close that and that. And we need to go to godoc/format. And then %v is the value in default format, so you're always safe just to use that. %t, capital T, is type, just like we've seen in the documentation. Capital T is kind of type. Whoa, that's capital T here too. Right? We could do lowercase t for true or false, Boolean. We could do base 2, binary, lowercase b. We could do lowercase d for decimal. We could do %x for hexadecimal. And, you know, just different ones. Floating point, string or slice, a pointer. Or the default for %v tells you what's used. The default for %v, these. So I like that capital T one. I've used that quite a bit. Ah, there we go. Formatting verbs. And the string. And then we don't see the default ones there. So here's
Use the capital T just to find out what the type variable is.
Yeah. You could also use a reflect package type of. So we've seen that, or that's somewhere in this code that I've shown, or you might see. So here I'm doing some formatting verbs, and I've got a variable A, hello world. So I could just print A, and I get hello world. I could print the address of A. I could print it with %v, which is the default value or formatting. I could do capital T, %capital T, and that gives me the type, string. I could try lowercase t, which would give me, I forget what lowercase t did. We just looked at it. What was it?
Boolean.
Oh, true or false. Yeah, so that doesn't make sense to it, right? We could do s, which gives me here's string, and q with quotes, right? Puts quotes around it. Yeah. You could do %%, and that just prints %. So that escaped it, you know. And so now I've got these little identifiers showing me which ones did what out to the left here. And here's %t false, right? I printed out false, so I didn't get that error that I had before down there. %v is the default. Always pretty safe with %v. And then you could do width and precision. So if you're printing out float, you could say, hey, I want this to always take up 20 spaces. That's your width. And then precision is how many decimal places, right? So this would be 2 decimal places right here. This is 2 decimal places. That's 2 decimal places. This is no decimals right there. So that's width and precision. So here's an example of width and precision. And, you know, printf. And, you know, you could see what they do down here actually. %v, %f, just for float, and then that gave me 2 decimal places, 2f. 9 to f took up 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, I don't know what. Here's 20 spaces, that's better, right? Like I've given 20 spaces and I have only used this of the 20, but the others are still there.
What happens if you don't give it enough spaces to get the precision?
No, it just fills it in. Yeah.
Like the 4 and 3.
So here, that's 4. I gave it 4 spaces and
yeah,
put in a whole bunch. Yeah.
But that would eliminate white space if it was a short number.
Yeah, but then you maybe don't have all your stuff. I don't know. It's just command line formatting. Examples of other verbs: GitHub user content format. Go by example. Take a look at it. So here is you know, just some other verbs you could look at and what they do. What is standard input for your operating system? So standard input, right, is I don't know. That's a good question. What's standard input for your operating system? Keyboard. Right? Keyboard standard in. Scanning. An analogous set function scans formatted text to yield values. Scan, scanf, scanline. Read from OS standard in. Fscan, fscan, fscanline. Read from a specified IO reader. Scan, scanf, scanline, read from an argument string. So string scan. Scanline, fscanline, and sscanline stop scanning at a new line and require that the items be followed by one. And F requires new lines in the input to match new lines in the format. The other routines treat new lines as spaces. Fsim file, read from a specified IO reader. IO is an input-output. So OS standard in and IO reader. I don't know if I want to say any more about all that. Yeah, so here's that file that we already saw, scanning. You know, scan line, how come scan line versus fscan line or sscan line? Like fscan line maybe would need some formatting character, formatting verb, and sscan line, string scan line would maybe be handed from, just like sprint prints to a string, maybe we'd just be passing it as a string instead of listen to the terminal. Right? Scan line here, we gave it, you know, that, and it was listening to the terminal. Fscan, fscan f, fscan line. IO reader. So a bit of review. Format package, print, scan, and sprint. Those should all make sense. String print is sprint. And variadic, you know, taking a unlimited number of parameters, arguments, defining function with unlimited number of parameters, and then passing in unlimited number of arguments, and then printing verbs, and receiving user input. And then there's godoc reflect, which reflects on type also. So that's how you would use that. I don't know if we saw that. I was taking that slide out. And some exercises. All right, I don't know what there is. Why don't you guys try string print with a formatting verb? So string print with a formatting verb.